Welcome to a Sunday. Sorry I wasn't here yesterday, the day before. I went and got my Mordania booster shot and suffered 2 days of fever and crap, so wasn't feeling all so hot to do anything. But I seem to be feeling better. Gotten over it. Yes, if you haven't already done it, yes, even though you might get a fever or something like that, or you get what they call COVID arm, where your arm feels like a dead weight because where the needle went in, still get the vaccine. A slight fever and stuff is better than dead or long-term COVID, which are now being equated to 1 in 4 people getting long-term COVID months after they've already had COVID. So, and the damage you can get apparently to key organs like heart, kidney, lungs, it's not worth it. Really isn't. So, today we're going to go and we're going to actually turn an S3, this guy here, and a Raspberry Pi, this guy here, into CircuitPython boards. So this is known as, we're going to do this one first. This is known as CircuitPython on bare metal for the Raspberry Pi. Now, at first when I did this, and I actually had a whole video lined up, but it was all a failure, I couldn't get it to work. And when I did get something onto it, it was failing all the time. Everything from USB disconnects to file system can't write, blah, blah. So I put the message on Scott's Deep Dive. He's the guy on Adafruit that did a lot of the work for the Raspberry Pis. And if you want really interesting and can ask questions of him, you see his show on Friday, and I think it's 2 o'clock Pacific, PDT, Pacific Daylight Time or Pacific Standard Time, depending on the season. That's when he does it. Although very, very, very soon he's going to have a new unit in the house, so he'll probably be on diaper duty forever. So he might not have a few shows in a row. We'll find out. But he did a lot of that, and I asked him some questions about this and that, and a couple other people came back and said basically, stop using the stable branch, doesn't work. And that was true. When you download stuff off of python.org for downloads for your Python, CircuitPython, CircuitPython.org. Let me find the web page. There is a place on here when you do downloads like this. So normally you would have this. They'll say stable 7.1.1 download blah blah blah, and then it'll say below it alpha, and then even below it will say this one, absolutely newest, browse the S3. So they store all the bleeding edge stuff on the Amazon S3 cloud. And when you go into here, you end up with what looks like a classical FTP site. So you go into English US, and here you will see, so there's the US 7.2 alpha, and it was done on the 11th, but on the 13th there was another bleeding edge release. So this is what I had to do, and so we are going to do the same thing. So I've already downloaded the image in the zip. Now our second trick for the Raspberry Pis you're going to need, and let me go back to overhead, is one of these. Basically, or something similar, you need to be able to write the microSD card. So here I have a microSD card. You buy these. If you look on Amazon and shop around a little bit, you can buy packs of these dirt cheap. So this happens to be a 16 gig one. This is more than enough. In fact, a 2 gig one would work more than enough. You have to remember that this S3 has 8 meg of storage. 2 meg will be used up by the CircuitPython, 2 meg for the OTG component, and the remaining 4 meg is your storage area. That's it. So having a little card here that says, 32 gig, yeah, you'll have 31 point something gig of CircuitPy drive. That's how big it frickin' is. So stick it in here. And I always have to look. In my case, it's always this way. And then on my bench here, I have, you can see one of the little windows, I have a straight USB-C going back to my USB-C 3.1 hub. Now, let's go back to here. So normally it pops open and says, as you can see, 14.7 gig. We're not going to mount it or anything like that. Okay? So what we need here is a writing tool and knowing where it is. So I happen to have the Raspberry Pi writing tool. Yes, you can get this for Linux, you can get it for Mac, you can get it for Windows. It's all fine and dandy. Use custom at the very bottom and go browse for your image. So I was doing Raspberry W2s before, these guys. This time we're going to change over to Raspberry Pi W. So I have one of those controllers right here. In fact, at the time I got it, they were very hard to get. So we want the zip drive, and you don't unpack the zip drive. Keep it as you see it. We open it up, we choose our media, and for me it's MXT USB storage, and we write it out. Yes. And we have the secret password thing. So there we go. We're writing it out, and it'll verify it, and then we'll be done with it. Now, when you use these with CircuitPython, and you notice you have your HDMI port, you have your USB port, and your USB power port. You do not have to put power on this. Only this port is needed. And the reason I know this is a W because it's sitting right there on the back. W, version 1.1. Okay, I do have other ones. So this is a W2, this guy right here, and this one here, for example, is a non-W. You can see that it doesn't have the it's a 1.3 Raspberry Pi Zero, but you can see that it doesn't have that chip there, and it's laid out a little differently. So if we go back to our there it says it's all done. You notice too that it now says boot. Okay, so we say continue, and we'll just minimize this. Now usually my safety thing for doing any of this is, of course, 3 syncs to make sure I flushed everything. And we put it in here, like so. And we're going to plug it in, like so. We should get a light at the bottom, like that, for a moment. There we go. What it does is it goes out and now makes the CircuitPy drive. If everything goes right, it should show up. Now I haven't done the Raspberry Pi Zero. I've only done the Raspberry Pi Zero 2. So that CircuitPy drive belongs to the macro pad that I use to flip screens here. It doesn't belong to this. So from what I've seen here so far, this is not working the way the zeros worked. Sorry, the number 2s worked. I'm going to go check my dmessage log. Ah, there we go. Just took a while to do it. So the second CircuitPy drive mount, 14.6 gig of space for CircuitPy on here. Ta-da! Okay, I was going to check, but we can still check. Dmessage. There it is. Raspberry Pi Zero W. Right, it's attached to SCSI here. Oops. Let me show the desktop. So there you go. The plug-in Zero Pi W mouse, whatever. Attached SCSI removable disk. There's our size of our drive. Interesting thing is, if you take this disk out and you put it back on the reader, this little thing, and put it in here, it'll show SDC1 and 2. But when you're plugged into here and through here, it only shows the SDC1. And as you can see, SDC1 is the CircuitPy drive. So this now has CircuitPy on it. Now we can go here to our thing and say File, Open Folder, CircuitPy, say OK. Okay. There's a choose board down here. If that happens like this, I find you might have to wait a moment for this to settle down, or create the workspace file, or even just exit this and come back in here again. Like close the folder and open the folder. Yeah, so it's complaining. So let's just close the folder for a sec. We'll do it that way. Close folder. File, open folder. There we go. See? Now we go find rasp. There's pi 0W. Okay? So there's a 0 pi W. Now what I'm going to, as I said, I always do, file, save a workspace out. And we'll call it RPI 0W. Okay. We'll open up VS Code in the settings file. Here we go. You can see the alpha right there. Everything's in place. Now, I can attempt a blink program, but it probably will not work, because if I remember correctly about these, the LED on here can only be used for one state or another. If I'm going to blink an LED, I have to actually hook it up to GPIO pins, and I don't have that set up. So, but close this, open the code up. There's hello world. Now we can connect to the serial monitor. There's our Raspberry Pi. So let's see, Control C, Control D. Hello world, right? Doink. It's running. Now this, when I was doing this with the other ones, this actually led to, actually on the S3s, led to a weird error from here. Whenever I wanted to click the port to be on, it was kept saying recursive ACM 0 can't do it, blah blah blah. It was like a really stupid error. It turned out I had a bad udev rule, and this is something you got to be careful of. So when you look at, let me find it. If we look at the path here, we're in etc udev rules.d, and in this directory, right, are all these rules. So when I install, for example, the ST-Link stuff, I end up with their rules. The Mini Pro, I ended with their rules. FTDI devices and their Handtech. You get the idea. All these different rules get installed in here. Okay. Now, one of the set of rules that was throwing me for a loop was Rule 50 and Rule 66. Now, let's 66 first, and less 50. This is the one that caused all the issue. So this rule here, okay, had this weird thing where they were doing symbol linking things here. And what they inadvertently did, this rule is doing, it was symbol linking the device back to itself, i.e. making a broken link. So of course it didn't work. And I realized that you really don't need to do this. I don't know why they're doing this. And then I'm not sure exactly where I got this set of rules from. Okay. So when I looked at I remmed them all out, and I looked at my other one, which is the one I think I built a long time ago, this one here. So the way this rule works, what's between the quotes is all together. Now what it's saying is this block, the pipe symbol, or this block, the pipe symbol, or this block. Okay? So it's saying if something comes up and it gets created that's USB 0 through 9, or ACM 0 through 9, or TTYS 0 through 9, set the mode to 0666. Okay? Now, I'm just going to back off the zoomy a little bit. Now, if we do this, okay, you can see that root owns it initially, dial out is the group, and yes, I could go to groups and there's a thing, there's dial out right there. I could add will m to dial out, okay, and then it would work. But there's a fault in that. If you change this file, you're going to have to log out of the desktop, basically cause X to restart a little bit, and then come back in for this group application to stick. If instead you just modify and make these udev rules with that 666 option on the end, then all you have to do is run that one, udev control reload, and then this one, tell the kernel to resense for plugged in device, and then replug your device in. No relog out, no none of that. It just works. Because now what's happening with those devices, as you can see here on this one, for example, it has world read write, meaning anyone can use this device at the moment. Now you might say, well, okay, but it's a security problem. There are two types of machines out in, well, I'll consider it two types. There's the machines that are doing a critical job and are exposed to the world. Okay, those are like gateways and stuff like that. And yes, you should be more careful about what you do with your permissions. On the other hand, if you're hiding behind your rock solid little firewall and everything like that, and like this box here is for development work, right? I don't need all this crap. Don't have to worry about it. It's not like someone's going to have shell access to this box and do something through my T2Y port, right? Let's just be reasonable about this, right? So don't sometimes go overboard. And sometimes when you read some of those security warnings that come up, oh, Red Hat is broken and this was this. If you read carefully the fine print on the security warning for it, a lot of them will say requires shell access. Meaning if this box was a shared box that multiple people log in, yes, then you have a security problem. If it's a single person always logging into the same box and it's not exposed to the world in that way, no. I wouldn't worry too much about that security issue. It's not like you're going to also instantly be contaminated or anything like that. It doesn't happen that way. Right? Yeah, sometimes the hype on some of these security warnings is way bigger than what is actually going to happen. Especially on a test box like this. Right? I mean, as far as I'm concerned, as long as I've got my home directory backed up somewhere, I can rebuild this box in a day. It doesn't really matter to me. Yes, it's annoying, but I can do it. It's okay. I can put all the software back in I installed, right? Not a problem. But this udev one threw me for a loop, and I couldn't figure out what was going on. But we do have CircuitPython bare bones on a Pi now. So let us do the S3. And I happen to have, of course, a fresh S3. So I actually already did one, this one here. We're going to do this one here. We're going to find out. So when you're interpreting these boxes, see the N8 and the R2? N8 is storage, NAND 8, and RAM 2. So there's 2 meg of RAM in here, 8 meg of storage. Okay. So I'm going to close the workspace off on this. Well, actually, let's just exit the serial port. Let's be nice about this. And close the workspace. Then dismount the drive, because this is, after all, CircuitPython, and we want to be nice, don't we? There we go. So now I have 3 zeros that are all prepped and ready to go. Okay. In fact, this one here, I'm going to put back in its container here. I had a nice little box for it. I've got for it. It's the only one. It fits the 0 perfectly. Yeah. Something like that. There we go. See? Card, HDMI. Now, one thing I haven't tried on here that's new, there is some code on Adafruit that allows you to see the REPL through the HDMI port. Haven't tried it yet. But I'm going to put that back in here, and I'm going to put the other 2 Raspberry Pis back in there just to get them out of the way. And this guy here, I'm going to put back in this little box. I saw something interesting about these. So I didn't get the 32 meg storage ones. But I found out that I couldn't have used it anyway, because apparently even the current 4.4 release branch wasn't working with 32 meg expresses. Not even working properly with 16. Now, someone on the person in Discord pointed me to a forum article, and in the forum article they talked about this and the patches needed to make the 16 to 32 work. Well, it turns out the core of this and everything else actually can address 1 gig of storage and 1 gig of RAM. And some people, they were taking this hat off, and down in this corner right over here was the chip that had the storage and everything on it, and they were replacing it with a new one. You know, doing the solder work and all that nice stuff, tricky work because it's all surface mount, and then this chip happens to be soldered where the pins are actually underneath, kind of like BGA work, ball grid array work. So they soldered it all, and then they end up patching the code, and they end up having one of these controllers with a gig of memory and a gig of space. And I was going, holy crap. Yeah, that's really pushing the hacking on that thing. I think the reason that Espressive doesn't actually ship a unit like that, right, is the chips are probably cost prohibitive to do it. I think it would raise one of these microcontrollers from, you know, the $20 mark to like the $100 mark pretty easily. And they wouldn't sell many of them. So they got to pick a model to sell. I still think if you're going to buy these units, get this one from these guys, or from Unexpected Maker. He's now got 16 meg versions of the 3 levels of these. A tiny one, a middle grade one, and a high end super one. And they got a bunch of extra features that these guys don't have, but they also have the same S3 and everything in it. So I would actually check on his store site if you want to get those versions. And they float between $18 and $22 for a board. So let us get out this one, and I'm going to just put my little card reader away. So this guy is our 8R2 and 8R2. Okay. So one of the things to observe on this thing, I've been using a lot the UART port to program to it instead of the USB port. Now, doing the CircuitPython requires you using the USB port. Now, I think one of the reasons was I was having issue with the ACM 0. Well, it turns out my error on this machine was, as you saw, a bad udev roll. Now it's all working perfectly. So first of all, having this, we need the files for this. And now, if we go back to our desktop here, we go to work and we go to controllers, and we have, we need a new one in here. So as you can see, I have some of my ESPs in here. I need another one in here. So I'm going to create a folder, and we will call this ESP32-S3 dev kit C-1-N8R2, because that's what this one is. We go back over here to the website. Okay, go into bin. Now what we're looking for in here is the ESPs. There we are. N8R2 DevKit CS3. We'll take US, and we'll take the bleeding edge. There's a UF2 and a bin. We'll take both of them. I haven't had to use the UF2 file. I just used the bin file. So we'll back up, and down here we will put it in here. We'll save. And we'll take, I just took the bin file, I believe. Yep, I need the UF2 file also, just in case. Okay, so back to our desktop here. So we got the files. So we need to program this. So I'm going to put this on. Currently it's programmed with ESP-IDF and it has the Blink program running. So I go here to here, and we'll CD one directory back, and we'll CD into, oops, R2. Okay, so now we need the code that we're going to use. Now we're going to need to use ESP tool to write this initial one out. There are two ESP tools actually installed into Linuxes. If you've installed the ESP IDF, that's where the second version of the tool comes. So if I go ESP, there is an ESP tool. Okay, and if I do version on this, we get this one. If I go up arrow my history a little bit, and we go to this one, I'm just going to borrow this path right here. Right? Let's see which version I get. See, this one here is 2.8, and this one here is 3.2 dev. Okay? If you try to use this 2.8 tool on this board, won't work because it's too old. You need the one out of the kit, and it happens to be out of the it might say 3.2. You know, the funny thing is that you think they would upgrade this to 4.4 dev, but they don't. But you need the one from the branch, the 4.4 branch, one designed to work with the S3 boards. So as you can see down here, all we did is that we ran this tool, but we passed a bunch of parameters. The port, and this is a tricky one. I need to know which port we are actually on. We're on ACM 1, I think. Let's find out. I need to unplug this and make sure I disconnected. Yeah, I disconnected. So reconnect. Okay, expressive, USB JTAG, ACM 1. So something else is using ACM 0 at the moment. So we can't use that. Back up to this. So first of all, That's the wrong line for this. We need that one. In Linux, if you hold down the control key and arrows on a line like this, you jump word by word. So we need to change this to a 1. Now, I can't remember if I have to put this in programming mode or not, or I'll just figure it out. So we'll try it without it first. There we go. We are writing. As you can see. So I just keep the notes for this in my notepad, this whole long command line. Okay. We should have written. Now I don't know if it'll come up and say CircuitPy. Yes, it does. There we go. So, whoops. Mount. Okay. Remember, both units I had here, the N8R8 and N8R2, have the same amount of storage. They just don't have the same amount of RAM in them. So now we can go, now that we've got this, like so, we can go to Circuitpython, sorry, our Visual Studio Code, and we can open a folder. We can open this folder. It'll create all the stuff in it. Now, we might not be able to choose a board right away until I actually come out and come back in. Let's find out. Nope, we can. ESP32. Okay, so the only one I see in here is the ESP32-S3 DevKit C1 N8R8. Now this could be simply because I need to rebuild the boards and the stubs directory again. But for this one should work fine, the R8. It just means the memory's a bit different. That's okay, we'll just pick this one. I will actually go and rebuild the boards and stubs later. So, of course, first thing I'm going to do is make a workspace file. ESP32-S3, and this is N8R2. We'll save it out. Okay. Open the code up. There's hello world. Let's see if we can connect to the REPL. Yep, no problem. Hello world. There it is. Now, in theory, the usual Blink program should work in here. Let's see if I got a copy of one. That's the INO Blink, CodePy Blink. That's the NeoPixel. Would this work in here? No, it would maybe. No, what we want, and I had this open already somewhere. Let's see if I can find it. You know, I really got to cut and paste this code. Since I used it, I think, on the other one, let me just go change over to that directory and see if its file has it. So we go into we are currently in CircuitPython, and we're storing this all in the drive. Oh, I have to plug that thing in. It's actually on the drive. That's okay. That's fine. We'll just get it out of the box and borrow the next USB connector here. Yeah, I did have it on there. So there's another CircuitPy. We'll mount this drive. And this code, yeah, it's 400. Let's copy it. And this code is 22 bytes. We'll delete it, and we'll paste one file. Okay, the bottom one. Get rid of you. Okay, there you go. NeoPixel 1. Okay. Now, I'm just going to get rid of the other ones. I don't want to wreck it. So this one, safely remove. So we can unplug it, put it back in the box. Okay. Now it's complaining because there's no NeoPixel. That's fine. What we want to do is circ up. We're just going to check update -s all. Okay. Now circ up, install NeoPixel. There we go. Now we're doing it correctly, see? So if we go back to here, Control C, Control L, I don't know, Control C, Control L, Control D, there we go. No errors this time. And we're using the NeoPixel on here in CircuitPython. Now, since I keep using this code all the time, Control A, Control C, where's my notepad? And Control T. Okay. Close. Okay, let's say new. There. Control V. And I'll just put this one beside my classical blink here. And this one goes here. This one I don't need to. And I'll save as NeoPixel blink. And we were putting it in, I think, in documents. Save. There we go. So now we have a sample code for doing NeoPixels. I have a sample code for Arduino, and I have a sample code of another way of doing NeoPixel. And this README I don't need to see. Oh, this one, yeah, I want to keep it. See, I saved the command lines for the writing the ESP tool. And then this one here was a something else. You ignore. But sometimes Notepad Q thinks that its tabbing is different from the default tabbing inside of Visual Studio Code. But there you go. As I said, you can't blink the Raspberry Pis until you figure out, put something on one of the pins. Because the LED on the Raspberry Pi doesn't allow for this. It's not an addressable LED, I think. There's some talk about getting access to it, but so far I haven't seen any working code that actually gets you to that one LED, the power / status LED. This one, on the other hand, has two different LEDs. This is kind of like a generic purpose all thingy LED, and this little tiny red one here is the power indicator LED. But there you go. Now we have an S3 all rigged in CircuitPython. Now, in theory, the next step I could be doing is see if I can access the Wi-Fi in here, like put Wi-Fi code onto this thing. So we will find out about that later, not right now. Because one thing I was going to go looking for in here in my file tree, this is just remembered this. I have these little LoRa Heltec LoRa 32 version 2 Wi-Fi with little OLED screens on it. It's another form of an ESP, but I can't load code on them anymore, and I can't figure out why. I think I'm missing a library, and I'm not sure which library I'm missing. So I am just going to go check my platform IO projects directory here, possibly the other. There's the ESP32 cam. The matrix. Nucleo. That's the development board with STM on it. Nucleo should actually be in the STM32 directory. There's the black pill. Arduino, I'm not sure I have the Haltic in here. Pika, PI, Mega, Arduino Zero, Adafruit Metro Mini. All the default code for Arduino ported over to Platform IO. No, so it's not in there. So somehow I did this. Now I can't find the code I used. Or the layout I used. Not sure. Now I don't even think I have encode here. No. Controllers. I don't think I have it in controllers. That's all Adafruit controllers. Oh, there's the Haltic. There's the Wi-Fi kit 32.zip. See, this is what I was working on, was this stuff. And I can't find my code for this. It doesn't work. Well, I follow their instructions and it doesn't work. I have to figure out what's going on. Yeah, so if we close this guy off here, just close the workspace. And we go to this guy here. Libraries. Installed. Fast LED, Adafruit fast, Adafruit fast. Updates, none installed. I wonder if I did this before my last reset of the operating system and stuff, and I misplaced the because what we're after is Haltec. I think that's the way you find it. No, LoRa. LoRa. ESP. Yeah, I mean my VM is acting differently even than this one is. I think I'd find it. Haltec. So there's all the Haltec stuff, and what I was after was this guy right here. So I might have actually installed it through, I might have done it through the IDE. Let's just check the old IDE. File, examples. Yeah, it looks like I might not have done it here. Well, or I might have done it and changed the OS since then. They did it a long time ago, so this is one of the betas of the new ID for it's actually RC3. I should actually update this. So it claims I have the Haltechs installed. So Haltech ESP32 dev boards by automation. It's installed. You'd think the file examples may be in here. Oh, there's a lot more in here. Here, Haltech ESP32 dev boards. What I was trying to do is the factory test for Wi-Fi LoRaWAN 32 boards. So there's a header file and a factory file. This one. Can we see a terminal? Well, I don't know. If you go like this here. Yeah, see compilation error 2. It's happening over here too. So has a big sign that it's missing a library here. So you can see it right down here that it's screwing up. Class Haltech ESP has no member name display, for example. So we're missing the display. And if I remember correctly, that was TTN something. TTN. This one here supports Haltech libraries and boards. ESP. I think if you install that. There's also an OLED thing you need. So if I build again, no, I think we're still doing, we're still missing a chunk in here. Yeah, so yeah, the display is not there. It's like I'm missing a chunk of the libraries for that one. And I have to look into it. So if it's not working here and it's not working on the VM machine, definitely I screwed things up. So we'll find out later. I don't need this. It's something I'll work on. But I did have it working because it actually has a Wi-Fi scan test on it and scanning my local network. So I did it once before, so I can do it again, but I just have to figure out how in the heck I did it. It's not very straightforward. I came close over there, except for something with the wire protocol. Not liking parameters being passed. So I'm not 100% sure about that. But doing the S3 stuff is a lot more interesting. It actually works. Now that I understand how to do it. Oh, there is a trick to this. I almost forgot. When we were writing the thing out, see this flash size detect in this number? By default, I took this line from the ESP tool when it was writing out code to this. Well, apparently it would write out the code at 0x1000000. So it was actually moving all the code forward in the space, the flash, and every time you wrote this to that spot, nothing happened. So you have to make sure that when you write the CircuitPython bin file, this one for example, you have to make sure you're writing it to this address, not the default address that ESP32-IDF was using. But just remember that you can actually write code to these boards at different blocks in the flash, and you can write more than one bin file at a given time. If you watch the ESP32-IDF build your program, it builds, I think, like 4 bin files. There's a boot file, there's something else, there's a code file. There's all different parts of the same thing it uses to run your program, but they're actually all written at different spots in the flash. So make sure that when you're dealing with the CircuitPython, you're only writing one bin file that you write at the very beginning. So, but given this, if you have this board, you should be able to be doing CircuitPython on the S3. I won't guarantee it's stable, because it's, after all, alpha. But it's getting there. It's workable. You can now blow it up. Now, I did go on over there and I found one of my C3 versions, not the S3, but the C3. And I did get CircuitPython running on it too, because those are also in let's see, where is that S3 reservoir? Where's the S3? I'll take S3 bucket listing there. In this thing here, if we go into the bin to look at all of them, you can actually see down here C3 dev kit 1M N4. It's actually in here. Okay. So N4 means there's 4 meg of flash on this, not 8. But yes. And everyone is comparing this actually to a replacement to the ESP, what was it called? 22 something 86? 88? 2688? Something like that. The older one. So now I think I have the Kaluga or the Solola, I can't remember. I haven't done anything with those yet. Just see if they can be turned into CircuitPython. But yes, this is your prototype where everything is blah 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 blah. All the CircuitPythons. There's a swan I worked on. But you get the idea. So I hope this helps people who are playing with the S3s get going and actually have CircuitPython instead of everything go through the Express. But I mean, hey, I don't know. You might love ESP32-IDF and live for the C code and go bah humbug to the Python code. Don't know. So at this point, I leave you a blink, 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 and I'll let you go at this, and I'll upload this.